This is just a little bit of an update. It's not going to be long. The product management people have told me that I'm not permitted to talk about some of the things that are happening, so I've had to rework my slides at the beginning. Morning here. I wanted to start with just talking about HPE's investment in DAOS and moving forward productization. Right now, I'm in the Chief Technology Office. I'm doing advanced development for a variety of things, DAOS being one of them. And currently, we've got 4 people now allocated to the project, so we're committed in earnest. We've got a test bed that has 20 DAOS servers in it and a variety of clients as a corporate resource. So we'll be using that for development of the product, making some enhancements that I'll talk a little bit about here in a couple of minutes. Also hosting internal and external POCs, so if other organizations want to understand DAOS, kick the tires on it, port an application, work on integrating some middleware with DAOS, they can use this test bed for that purpose. So we're trying to build awareness within HPE, which is, of course, a large organization, and also to provide external POCs to customers who would like to kick the tires on it but don't really want to buy the gear, don't want to invest in the hardware. This test bed is in a DMZ so that we can gain access to it from the outside of the company as well as the inside of the company, and run POCs and benchmarks with customers. So if you'd like to run one yourself, or you know someone who would like to run some functional testing or some performance testing, please contact me. And let's see, the storage R&D organization is now beginning the technology transfer activity, which is really what happens when our CTO office seeds some technology and then shifts it into this productization phase. And we're beginning to get allocations of resources from the R&D organization, particularly the architecture group. We'll be wrapping, system administration, and we'll be wrapping productization elements around it. And we'll also be hardening the code with our test engineering organization. So we've got a test framework that we use for other storage products, and so porting that over so that it works on the DAOS test bed and with the DAOS software, so that we can drive as many bugs out of the code base as we can over the next months as we ramp toward productization. We want to make sure that our customers have a good experience with the data path. So we'll be contributing stability as well over the next months as we move this direction. And then our AI and ML organization, we've got an AI test bed in Grenoble. They have acquired a small DAOS cluster and have attached it to that test bed for hosting AI and ML POCs. So we'll be doing some additional benchmarking with AI and ML frameworks. We think it's a really good target market for DAOS. And so we want to make sure that when we bring this product out, it's not just for the exascale, not just for the supercomputing HPC environment, but also for other technical computing environments, down market at rack scale and with GPUs. So that's what we're up to organizationally. Some contributions that we've made recently. Kelsey mentioned the metadata on SSD work. The purpose of this, of course, is to decouple DAOS from a requirement for persistent memory hardware so that we can run on CPUs that have just NVMe and DRAM. And so we've been making contributions to the alternative memory allocator and metadata on NVMe so that we can commit that data out to NVMe transactionally. And I've got a little slide that shows our preliminary performance benchmarks of that aspect of this development work. We've also implemented some client-side metrics. I mentioned this in our last meeting, actually a year ago. Just wanted to bring it up again to let you know that that's available. This enables applications to be profiled. This integrates with the DAOS client so that applications can see their I/O profiles and tune. And what we're finding is that as applications are connected to DAOS, they really can't sometimes take advantage of all the performance that it offers, the latency and concurrency that it offers, but they may not know exactly what to do to correct that. So the goal of this is to give them the output that's necessary in order to evaluate how they may want to change their I/O strategies inside the applications to improve and take advantage of the performance that DAOS can offer. The third thing is a TensorFlow I/O, and this is an ML framework that's popular, and the goal of this was to enable TensorFlow to more efficiently interact with DAOS. This was one of those examples where TensorFlow really wasn't doing I/O very efficiently. Also, we fixed a bunch of bugs in the initial implementation, and you couldn't, the way it was implemented, you couldn't build TensorFlow without all of the DAOS client code there. And so we made the DAOS client dynamically loadable, and we basically stubbed it off so that you could build the TensorFlow software without the plugin available, and that enabled it to go upstream. It wasn't moving upstream into the public code base without those changes. Some PyDAOS tuning. Again, this exposes DAOS objects as Pythonic data structures. We've changed that around, once again, optimizing I/O to use a large single event queue. And with that, and avoided is set up and tear down for every put and get call. The initial implementation was functional, it just wasn't performant. There's another example of application enablement that benefits from client-side profiling. The next one here is Ray Plasma. So this is an Apache project. Plasma is an in-memory object store, and it's enabled now with DAOS so that you can access that data in that object store directly from DAOS. And I have a little picture that I'll show you about how that works internally functionally. We also did a little plugin for YCSB to do some DAOS benchmarking. And so this is the Yahoo Cloud serving benchmark. It's been around for a while. It hasn't really been updated, but it's a great key value store comparison between different databases. And so we wanted to put DAOS up against a variety of databases and see how it stacked up. And so we built this plugin so that you could run it and compare DAOS on an ongoing basis for its lean key value store. All these things are available in open source. If you'd like any of them, please contact me. We're willing to share. Quickly, this metadata on SSD work. This is all preliminary benchmarks. They're not, the code isn't finished, obviously, and this is only one fraction of the code base. And so the performance implications are larger than the scope of this allocator. But the bottom line here is that when we're committing to persistent memory or to RAM with the persistent memory development kit, our latencies are significantly higher than the latencies we're getting when we're using our allocator using only DRAM. And the reason that we're getting that is because we don't have all the transactional overhead, a lot of the things that were in PMDK to handle persistent memory, we've been able to rip out and streamline the code. And this is for updates, and then for fetches, our fetches are equivalent in performance to the existing allocator. So that's a plus. Next project is the client-side metrics. This is just an interceptor library, the diagram of the interceptor library that's bolted into the DAOS client library that enables us to monitor, providing counters and statistics and some distributions that enable us to profile applications. Here's a little bit of the output. Some pool-related RPCs here, container-related RPCs, object-specific RPCs, then some object statistics, updates and fetches, and then updates using various replication factors, so that if you're using more than one type of replication, you can see that output there. and then updates using varied erasure coding. So these are the outputs that you can get from that client library to profile what your application is doing when it interacts with DAOS. This is the Ray plasma thing. Really quickly, the idea is that in the existing model, you would use an in-memory object store and then write the data out, and then it would overflow into local NVMe. And that was a horizontal model that could occur across multiple nodes. However, if any node, node N, wanted access to the objects that were in another object store, it would reach across the network and grab it out of the other object store, which would then reach it into the NVMe device and pull it up and push it across. In the new implementation, the local object store overflows directly to DAOS, and then if any other node needs access to the data, it can reach down into DAOS directly and pull it up. So it saves a hop and saves resources on the opposing node. Kind of an eye chart here. This really just talks about system administration enablement. We have a cluster management software package called HPCM. It's the HPE Performance Cluster Manager. This is what some of our customers use to deploy very large supercomputers. We've got a couple of these, but this is the one that came through SGI and has been supported for quite some time. And what we've done is we've added some DAOS-related functionality to that through shell scripting to extend the command set from HPCM so that you can deploy DAOS clusters relatively easily. So if you take HPCM and drop it on say a HPE DL'22 as a management server, and then you build a DAOS cluster, you can do bare metal installs, bare metal management all the way up, bring the cluster up, and then deploy DAOS on top of it and configure the network interfaces for cluster communications with DAOS. So, and that's all available as well. We're freely sharing that. And we're using this in our test bed to build mini clusters for customers who want to test in a little sandbox. And we're also providing it to customers who want to build small DAOS clusters today. The last thing I'll mention is also something that I talked about the last time we were all together, but this is now a reality. We're able to ship these. This is not an HPE product. It's kind of a bundled solution or reference implementation. Everything is available off the shelf. We use HPCM to manage this. We're using some small management servers and some Aruba switches at the top of the rack, and clusters of DL'22s, which are dual socket servers, dual socket one-use servers. We're shipping them as one socket servers, however, instead of dual socket, because we hit power limits in a rack. And for these early systems, we feel like going water cooling is really the objective here. Customers want to build relatively small clusters and learn more about DAOS and integrate it with it and run it in relatively small scale. So we'll support either InfiniBand, HDR, or our Slingshot network, 200 gigabit Slingshot network, and get about 700 gigabytes a second write throughput and 350 gigabytes a second read throughput. That's driven by the speed of the SSDs and the configuration, and over 50 million IOPS out of the system. So it's an appreciably sized storage infrastructure for just taking a look at DAOS. The individual elements are sold and supported separately. We provide a cookbook, and if you want to talk to an HPE sales rep, they can configure up a BOM for you and either assemble it in the field at a customer site, or we can pre-assemble it in the factory. But it is kind of a box of parts at this point. We are able to support customers in the field who want to buy this. And then just an internal diagram of the server. We're focused on a performance configuration. We're using the Intel 6338 CPU. We're only putting 4 NVMe SSDs, the fastest enterprise SSDs that are offered with the server in it, because the bandwidth of those balances the bandwidth of an HDR NIC. So it really is a balanced configuration front and back with 128 gigabyte DCP-MM Optane 200 DIMMs. And then for customers who want a higher capacity configuration, they strand a little bit of bandwidth, they strand a little bit of IOPS inside the server. We can add a couple more NVMe SSDs, and then we can also increase the capacity of those SSDs if that's desired. But the people that have talked to us about this really prefer to buy the performance configuration that that only has enough storage where the controllers don't bottleneck access to the media, and the processors are able to deliver all the IOPS. So that's pretty much really it. That's all I had available to talk about. And any questions? Sure. So the question is, how do we access the HPE lab testbed environment? You send an email to me, and then that'd be great, yes. Well, so you would gain access to a subset of the nodes that we allocated to you, and you would have user level access. You would not have root access to those nodes. Well, we're willing to work with you on your specific requirements in the test bed. If you have needs for pseudo privileges for specific requirements, it's really my engineering team that runs this test bed, and we can make decisions about what access you're provided. There are some limits that HPE puts on what privileges any user in that demilitarized zone can have. But within those constraints, the equipment's entirely ours, and we would allocate you your own set of nodes. And that set of nodes, we can provide whatever access you need in order to get it done. Lance.evans@hpe.com. Yeah, I'm going to need to run because I've got another meeting. So unfortunately, if you can hand me one on the way out, I'm happy to send you an email. Other questions? We use 16 gig. We populate every DIMM slot with an Optane DIMM and a DRAM DIMM, and we use the fastest RAM that the processor will support. We use the smallest RAM footprint we can get to save money, and we don't have a problem with it. If we want to hyper converge, if we want to put the client on the server and do things like that, then we have to figure that out. I mean, DAOS is pretty core intensive, as you probably know. If you really want the IOPS out of it, so it's really about how many cores per SSD that you want to allocate to the server. So if you want to run something else there, that tends to be the thing. RAM, no issue. Any other questions? All right, thanks very much.